You know, Mars has moons, right? Two of them, actually, Phobos and Deimos. But here's the thing, they are cosmic oddballs. Seriously, there's some of the strangest satellites in the entire solar system. And for decades, scientists have been locked in this huge debate about where they even came from. Okay, let's dive right into this cosmic mystery. So, first off, if you're picturing a big, beautiful, round sphere like our own moon, just throw that image right out. Phobos and Deimos are, well, they're more like cosmic potatoes. They're lumpy, they're irregular, and they're a far cry from what we usually think of as a moon. And that odd shape? That's our very first clue that their origin story is anything but ordinary. And when I say they're tiny, I really mean it. Phobos, which is the bigger of the two, is only about 22 kilometers across. Now, to put that in perspective, our moon is over 3,400 kilometers wide. You could literally fit the entire moon of Phobos inside a medium-sized city. They're basically just giant, tumbling space rocks. And all of this brings us to the central question that has been puzzling astronomers for more than a century. Where did these two weird little moons come from? Were they born with Mars? Were they stolen from somewhere else? The scientific jury is still out, and there are two leading theories battling it out for the top spot. All right, so theory number one. This one paints a picture of Phobos and Deimos as interlopers, a couple of cosmic stowaways that just got a little too close to Mars and never left. This is called the captured asteroid hypothesis. And on the surface, it seems like a total no-brainer, right? I mean, the moons look like asteroids, and their composition seems to match the C-type asteroids that are really common in the nearby asteroid belt. The idea is simple. They were just minding their own business, drifted a little too close to Mars, and the planet's gravity just snagged them for good. But here's where that simple theory hits a major snag. A really big one. See, when a planet's gravity captures a random object, the orbit should be chaotic and elliptical, like a stretched-out oval at some weird angle. But Phobos and Deimos, they have these beautiful, neat, almost perfectly circular orbits, and they're right above Mars's equator. From a physics perspective, a simple capture just can't make orbits that clean. It's kind of impossible. So what gives? How can they look like asteroids but orbit like perfect little moons? Well, some really clever scientists came up with a twist on the capture theory. What if Phobos wasn't traveling alone? What if it was part of a binary system? Two asteroids orbiting each other as they drifted through space. Okay, so here's how it would have played out. As this asteroid pair flies by Mars, the planet's gravity would pull a bit harder on the closer one, basically ripping the two apart. One of the asteroids would get flung away, shot out into deep space, and in doing so, it would act like a brake, carrying away all that extra energy that normally makes capture so hard. This would slow down the other asteroid just enough for it to settle into the stable, circular orbit we see today. It's a pretty elegant solution to a very tricky physics problem. But that's just one side of the story. There's a whole other theory, and this one is, well, it's a lot more dramatic. This idea suggests the moons weren't captured at all. They were born from Mars itself in a truly cataclysmic event. This is the giant impact hypothesis. And if that sounds familiar, it should. It's the same leading theory for how we got our own moon. The idea is that early in its history, a huge object smashed right into Mars. The collision would have been so powerful, it blasted a massive cloud of molten rock and debris into orbit. Then, over millions of years, that debris would have clumped together, eventually forming Phobos and Deimos. And get this, we might still be able to see the crime scene. The Borealis Basin, this massive depression covering a staggering 40% of Mars's northern hemisphere, is thought by many to be the scar left behind by this ancient collision. If they're right, it is the largest impact crater in the entire solar system. The object that could cause that kind of damage would have been absolutely gigantic. We're talking about a protoplanet with something like 2% of the mass of Mars itself. An impact on that scale would have totally reshaped the planet and filled its orbit with enough material to form dozens of moons. So we've got two really compelling theories. Were they cosmic stowaways, or were they born from a violent collision? How on earth do we figure out which one is right? Well, as it turns out, the answer might just come down to a single, crucial clue. It all boils down to water, H2O. You see, the two theories make completely different predictions about it. If the moons are captured asteroids, well, they could be pretty water-rich, just like a lot of the carbonaceous asteroids we've studied. But if they were born from a giant impact, the insane heat from that collision would have instantly boiled off any water. Poof! It would have just escaped into space, leaving behind 2 bone-dry moons. So the question is simple. Are the moons wet or are they dry? Answering that one question could solve this mystery once and for all. But to do that, we can't just keep looking through telescopes. We've got to go there. We need to get our hands on a sample. And believe it or not, that is exactly what's about to happen. The Japanese space agency, JAXA, is launching the Martian Moons Exploration Mission, or MMX for short. This is an incredibly ambitious plan. The spacecraft is set to launch in 2026, travel all the way to Mars, actually land on Phobos, scoop up a sample of its surface, and then bring it all the way back to Earth in 2029. It's an absolutely incredible thought, isn't it? Sometime within the next decade, a few grams of dust, just a few grains collected from a tiny potato-shaped moon millions of miles away, could finally tell us the violent and mysterious origin story of Mars's 2 strange children. It might just rewrite our entire understanding of how planets and their moons come to be all across the cosmos.